Okay, it's started now. Okay, so okay, so let's return here another time. We have application for the linked list. Some example. First example, we will create a linear linked list. Okay, that will add nodes in order. So every time we inserting a new node, we will insert it in the correct location. So if we have linked list like this, we will have the head. Head, we don't need its data in this example. In other example, we use the head data. Okay, in this example, we will have a static head that have any data, not we will take this example to keep employee names in alphabetical order. So if we have employee, for example, Ali, Nihad, Lana, then it will be like this in the list. Head that only have the head, not the starting. Okay. Like this is example. Ali will be the first one because it's alphabetical order. And then Lana and then Nihad. So every time we want to insert, we will insert in the correct order. So every time we need to search where to insert depending on the entered data and okay. So what we need to create the node. Okay, we need search function to search where to insert. When I want to insert a new node, for example, Ahmad, or let me choose Kamil, for example. So we have to search first where to insert it, depending on alphabetical order. So we found that this a place here, then we can insert it as we known from the previous lecture. Okay. Also for deleting, we need to search which one we want to delete. And also we need another function to find the maximum number of characters. This means the longest name. Okay. So let's see the functions. First, we have the node creation. This is the structure of the node. We have names. We need it because our example, it's about to order the names in the linked list or insert the names in order. And we create a new data type definition. This means new data type from structure employee. because we don't want every time to write structure employee node, blah, blah, blah. We create a node as a structure employee. So every time we want to define list or pointer to the list, we just write node and then the pointer. Like this, we have head pointer, which should be always on the first node. And we have a new node when we want to create a new node and insert it. And the previous, this help us when we need to search for the place to insert the node, and to delete when we want to search for a specific node to or record to delete it. Okay, we will use these pointers for the node. So first function, it's to search in the list. Search the place to insert a new node. Okay, we will return to this function. Okay, first we see add node. To understand this, okay, let's start from the main function. To understand this, at the beginning, we create a head. Create a head node. Because as we said, in this example, we need head node and it have data like this, top of the list. It's not part from our data, just we need to keep the top of the list. So we create node, we called it head, so it's head like this. Then we put data inside the name in the head. It have name and next pointer. The next pointer will be at null. So we just created here the first node or the head node. Now we can add names or delete names or find the longest name. Let's see one by one. To add name, first we ask the user to insert the name, enter the name to be added, okay? Then we take this name by our function add s or add name. So now we return to add. How to add? We take the name. Before start adding, we have like this, as we mentioned. We have head. It's have the statement top of the list, and it's next to the null. Now, for example, we enter name Ali. Or let me enter Nihad first. Okay, when we ask the user to give name, he said Nihad. Okay, now we want to create a new node. New node. And create a new node like this. Node, memory allocating, dynamic memory allocating from type node pointer and size node. Now we just string copy, put the string or the name inside the part from the node that have name. So it's like this. We copy nihad string to the node name, part of the name. Okay. Now it's like this. Search for a place for this name. Okay. Here we just give the name. Like you said, not the new node. No, only the name. To search a place to insert this name. Now, look to the search. We take the name. In our example, Nihad. Okay. Now we said that create P pointer and it's pointed to the head. Head have top blah blah. It's not our job. It's static, okay? And it's to the null now. B equal head. So P pointed here. Previous also pointed to the head. Okay, good. While P next, not null. Is it not null? No. P next, it's null. So we finished here. We return from the search. What this means? This means it's first node actually. So a previous node, it's the head because it's first node. Okay, good. Then previous node or a new node. Next equal previous now here, depending on the search. Why? Because as you see that when we define a previous, it's a global, not local. So if you change it here in the insert, in the search, it will also affect here. So previous here, I said next of our new node equal previous next, so it's equal null. Because this equal null. And the previous next pointed to the new node. So we create, we add this node to the linked list. Okay, like this. Okay, let's see if we want to start to add. If we want to add a new name. So when we ask the user here, when we ask the user to add a new name, for example, he entered Ali. Okay, good. So the new name is Ali. How to add it? New name, Ali. So in new node, now new node, not here. We created it again. So new node. Okay. And we put the name inside it, which is Ali. Now we're searching for the place to insert Ali. name. Okay, so we're searching for the place to insert Ali name. Now we have like this. We have the new name Ali. We have P from type node and P equals a head. Our list now like this. We have head, and we have P, and it's actually have, okay, top blah blah. It's already have because we added before Nihad. Like this, yes. So we said P pointed to the head, previous pointed to the head also. Now until P dot next not equal null. Yes, it's not equal null. So we go inside the while. P pointed to the P next. So P moved from here to the next. Then we compare. I think you already know this function from the string lecture note before, I think 3 or 4 weeks, yes. So we compare between these two strings. The string that I search for it and the string that pointed by P. If the string pointed by P more than the string we searched for it or equal it, we break. Okay, we have Ali and Nihad. Ali is the searching string, and Nihad the name that pointed by P. Actually, it's now Nihad, it's bigger than alphabet of name Ali. So we will break. When we break, we have previous at the head and P at Nihad. So we need to insert here after the previous. Okay, so add now, we said new node next will be pointed to the previous. Where's the previous? Still in the head. So next of new node equal next of previous, which is here. Okay, and previous next, this one, now pointed where? Pointed to the new node, pointed here. So like this, we insert Ali between Nihad and the head, and so on. If you want to insert, for example, Walid name, you will see that the previous like this. Previous will stop here. Here. Okay, if we want to insert Walid name, okay, you will search. You will find, you will not found by string compare this any name bigger than Walid. So you will move previous also here. Then you will see that P next equal null. So you will stop. So you will find the previous at the last node because we did not found any name bigger than Walid name. So like this, we can insert in order. What about if we want to insert numbers? It's much easy. Instead of string compare, you can use only the string, any string variable, compare with more than or equal the other variable. This is the searching one, and this is the number that you want to search. If it's number, because it's about a string, we use a string compare to compare. I think comparing number even much easier. Okay, what about delete node? Also, to delete node, we need to search about this node. Okay. Now, when you search here about node to delete it, what will happen? For example, if we have list like this, we have head. We have now Ali and Lana and Nihad. It's order because when we add in order. Okay, look, if I want to delete name, I have to search about it first. What if I want to delete name Walid? What will happen like this? When you ask the user to enter name to be deleted, he entered Walid. And we don't have Walid in our list. So we will search. Searching will be like this. P pointed here and the previous pointed here. Then while P not equal null, P to the next, P to the next. Now compare between P name and the search name, which is Walid. Okay. Is it bigger? No. So previous equal P. Okay. So while another time P next, not null. So P move to the next. Compare another time. It's not bigger than we moved. Previous here. Another time we will have P here and previous here. Okay. Now another time. P to the next. This means to the null. Then we comparing here. We will not find. Sorry, we will not move here. Okay. We will reach like this. P here. P next. Not null? No. P next null. Then we will stop because this while will be end. So it's like this. At the end, we will have P and the previous pointed to Nihad, which is considered the name before the name that we want to delete. But as you can see, we don't have this name. Actually, we have null. So when we want to delete, actually to delete equal next of the previous. When we searched like this, names, okay. So it's top, and this one head, this one Ali, Lana, and Nihad. Okay, null. And like this, we have a previous here pointed to Nihad. But actually, we don't know yet if Walid exists or not exists here. That's why we want to check. We search the place of Walid because we found that Walid is still bigger than this one, and we finish. But we don't know if we finish because it's reached null, or because we found the name, or because we found a bigger name. So we don't have the name actually. So we have to check this. Now to delete equal previous next, this means to delete here. And it's impossible to delete, okay, to delete the name inside the null. So we will check first, if not to delete. This means to delete here actually pointed where? Pointed to the null. So this is the meaning of not to delete. This means this name not in the list. Why? Because to delete here pointed to the null. Okay, what about if we searching for not, I will also give example if we searching for name also not exist, but in the middle. So merged, for example. Merged name should be between Lana and Nihad if there is a name, yes? So we searching for merged. When we searching for merged using this one, okay, we will have like this. We will have previous pointed to Lana because this should be the place for merged. So previous should point to Lana and P here. And we stop, but we don't know if this one merged or not yet. So here, the previous pointer stop here. And according to our guess, okay, just a guess now, that the one after the previous, this one should be the one that we want to delete. Yes, so we said to delete equal previous next. This means to delete this one. But actually this one not the correct one according to our understanding. Yes, so we have to compare first to see if it's the correct one or not. So now not to delete, no, to delete pointed to something, not to the null. So we enter the else. We make a string compare between the name to be deleted and the required name. If it's equal 0, then it's the correct name. But actually, when you compare between Majd and Nihad here, it's not equal 0. So you will go to the else, which is this name is not in the list. We found the place, but we did not found the name. It's like this. Okay. Now, the other possibility that we have name like this, Nihad, and we want to delete it. So we will have same. This is the previous, okay, and P pointed here. Now to delete pointed here, and we ask string compare between to delete, which have Nihad, and our searching string, which is Nihad. It's equal 0 because string compare. If you have same string, then the return value from the STR compare is 0. So it's the same name. So we need to delete this. How to delete it? We make the previous next pointed to the next of to delete. If it's pointed to another node, then it will point to another node. It pointed to null now, so also this one pointed to null. Now we can free the memory from this node and delete it. So like this, we can delete. Okay, traverse, I think we already take it how to print the content of the list. We need only a pointer P to move from one node to another node and print the content. What about find the longest record? Actually, we will use string length. Same thing. We have list. We have head here. Then we will start like this. We don't want even in the traverse, even in the delete, even in every time, the head, it's not part from our data. That's why we move next. We move P next before start printing or before start searching for our value. Okay, that's why we start P on the head like this because it should start from the head. Then we move P to the next because this actually is the first node that we want to start for it. The head contain static data, not from our data, not the name. It contain the sentence top of the linked list. Yes. So we will have P at the head, then we moved it to the next. And longest, we consider like comparing any numbers inside the array to find the biggest one. You consider the biggest one or the longest one first one. Then you will search until you reach the null. You will compare the lengths of okay, here we move, then okay, P on the head, then P to the next, then longest equal P. We should move this first. Like this, only we lose one. We lose one process. I mean, at the beginning, we compare between our place with our place. So it's not having any sense to compare like this before move to the next. Okay, this in the code should be here. I mean, we first consider first node, it's the longest one. Then we move P here and compare between this one and this one. We compare between P name and longest name. If the P name bigger than the longest name, so the longest become B. And so on. Move P to the next. Is it longest or not? If not, you just move P to the next and so on. Let me try it with data to show you the steps. We have Ali, which is 3 characters. We have Lana, which is 4 characters. We have I need 3 characters. What name should we use? ABC. Okay, which is 3 characters. And we have Nihad, which is 5. So actually the longest one, this one, yes, Nihad. But let's see how our code working here. To find the longest string. Only I want to move this one here because it's correct. Like this, it's correct, and it will give you the correct result. But for the best practice, we should move P first before comparing, not after comparing, okay? Because like this, you lose only one extra operation. You make one extra loop if you have if you moving P after, not before. Okay, at the beginning, we will have P here. And we consider this the longest one. So longest one at the beginning, what name? Ali. Now we move P to the next because we ask P not equal null, yes. So P here. Now we compare the name inside P and the name inside the longest. Okay, which one have more characters? Lana. What will we do? So, like this, P bigger than or equal longest one? Yes. So the longest one become P. We move here. Longest. Okay, good. Then return to while and move P to the next. We ask another time. P name, which is APC. Is it longest? The name here? No. So we will not do anything. We continue. When we continue, we will move P to the next. Then still now Lana longest after APC. Okay. We ask if P name, which is Nihad, longest than the longest here, which is Lana, it's yes. So this condition yes, this means we make the longest point to P. It's not here now, it's point here. P, okay, it should be like this. P dot next. If P dot next not null, it's null. So we will stop here. Okay, let me change this very quickly before I forget. Okay. This is the code, same code. I just want to change this one, finds longest. Okay. Next. And this one, I will bring it here. The previous one correct, but like this, we have one step less, one loop less, better practice. Then let's now try our code. Okay, press any key. Now list is still empty. Okay, this is the main menu. We want to add names. Enter the name, for example, Nihad. Okay, continue. Add another name. For example, Ali. Now Ali should be inserted before Nihad. As you can see, Ali before Nihad. Another name, Lana. Okay, Ali, Lana, Nihad. Okay, now let's find a name. First name we tried, Walid. Oh, what happened? Okay, find a name, 3. Oh, this finds the longest name. Okay, we want to delete a name, sorry. This is the longest record, Nihad, yes, longest record, Nihad. Let me add another name, which is ABC. ABC. It should be O, because ABC, let it M, start with M. Okay, starting with M, max, anything. Okay, it's here. Now find the longest one. It's still Nihad. Okay, now let's try to delete, for example, Walid. Walid not here, and it's after Nihad should be. So this name not in the list, is not in the list, should be is. Okay, let now another time try to delete A. It's not in the list. Try to delete max. Okay, already deleted. So it's like this. Let me just now, before I forget to change this one, Okay. This changed part. So find the longest. This is a new find longest. Just I changed this because I like to be everything perfect. To be perfect, it should be like this, not like a previous one. Previous one correct, but make one extra loop. If you understand, first loop, we compare the longest with B and they stay in the same one. Then we move B. No, we should move P to the next node, then compare the previous one with it. So this only the point here. So this is the main function. For the main function, we create, as I mentioned, the head node, which is static. We don't need to read it. We don't need to print it. We don't need to search inside it. So every time we will move next to the head and start our process. Here every time we traverse the list, we print the list. And then we have this main menu, add name, delete name, find the longest name. And to add name, we ask the user first to give us the name, then we add it in alphabetical order. And here, to delete it, we ask the user to insert the name, then we search for the name and delete it. Find the longest. We don't need anything from the user, we need the list. We search in the list for the longest record. Okay, this first application. Second application, okay, we can take a break for 5 minutes or 7 minutes until 1:50. So we can take a break till 1:50 for 7 minutes. Okay, see you after 7 minutes with the new applications. Okay. Okay, Assalamu alaikum again. Assalamu alaikum again. Please raise your hand if you are around. Okay, good. We continue with a new application. Okay, in this application also, or this example for the linked list, we want to build application to do the following operation. We have students information like a student number, name, midterm exam, and final exam. The basic operation, add and remove record, listing students. This means printing the data or traverse the data of the students. Also, we will calculate the total grade depending on the midterm exam 40% and for final exam 60%. Also, we can list or traverse or print all the information of the students and find the students with the highest total grade. Okay, this means his total grade or the final grade is the highest one between the students. And also we want a function to calculate the average for the student's grade. Okay. First thing, as we mentioned here, number, name, midterm exam, final exam. Then we have structure for the students, have student number, name, midterm exam, or midterm and final term marks. And we have also next pointer for the next node. Then we define a new data type from this structure student. We named it node. For the node, we create pointer from the type node, which is head, a new node. I think now you are familiar with the names. Previous node and highest node to point the highest score. Okay. Now about creating the list, we ask the user how many students you want to add. For example, 3, then for loop from 0 until before 2. This means you can start from 1, it's okay, up to you. If you start from 1, this means until less than or equal n. If you start from 0, this means until less than. Anyway, we need 3 times because 3 times for this loop because we have 3 students. First node, it's different than any other node. First node, it should have the head. So we create the new node. When we have the loop at 0, this means first node. We already talked it last time. So we create a new node and make the head point to the first node. So we have student information, for example, student number 100, his name Omar, his midterm 90 and final 90, for example, and we have head like this. Now, else, okay, This means cell for loop. Of course, we finished here the if statement. So this is the end of the for loop. We read the information. Okay, give me the student number, give me the student name, midterm mark, and give me the final. Then next loop k equal 1. So we will not enter here, we will enter here. We have a new node. Node. Okay, this is a new node. Okay, this a new node. Okay, I don't know why I write this one. Anyway, we should have like this a new node only without this one. It's working, correct. It's not a problem. Okay, anyway, we create a new node like this. We read information, for example, 200 and name Ali and grade, for example, 80 and 90, anything. Then we continue. We make, okay, that's why I make the, oh, this is correct, okay. Because first time we have a new node here, so this is correct. It's another way. I did not use pointer P. I use the pointer, so it should be like this. I use the pointer new node every time. So first time new node here. So we create next one a new node or a node without any name. A node. We create a node pointed by next of the new node because the new node at the beginning here. Now we move the new node to the next. Become here. And when we add another node, we said a new node next, it's the other node we built, then we move the new node here. So this is correct, okay? You cannot do it without this one, except if you have another pointer P and move tab P itself, okay? Now after finish, new node dot next to the null. Okay, this operation it's same like we take before. There is no anything new, just create a list. And printing the list also same thing. Until P not equal null, print, of course, P at the beginning. If we have list like this, we have head always point here. So we make P point here. P not null, yes. Then print the data. After printing the data, P to the next. And so on until P to the null, we will finish. Just listing the students. I'm very quick here because listing the students or traverse and create list, we already take it many times and even add a student. But as a revision, I will mention add a student another time. Okay, for add a student, it's like this. When we have already a list like this, And we have head here. Look, we don't need to pass parameter or to return anything here. Why? Because head and node and everything, it's a global. So it's available for all the functions. And when it change inside any function, it will that change will be affected for all the program, for the head and a new node and for anything global. Okay, so we don't need head as a passing parameter or node as a return value here. First, we create a new node to be added like this, a new node. Okay, and we ask the user to enter the information, for example, number 300 and name Nihad and midterm 70, final 80, and so on. After that, we will ask the user where to insert it. Enter student number that a new record will be added before it. Before which student? For example, we have student number 100, 200, and 400. If he said before student 400, then we need to insert here. If he said before 100, this means before the head. It's different way. If before 200 here. If he said 0, we said if 0, then he will add to the end of the list here. So we will check which one he used. First, we make P pointed to the head. P, because we cannot move the head. We will have another pointer P to move inside the linked list. Now we combine and the student number. If we said add before 100, so student number 100. And P number 100, this means a place that we stopped. We stopped here at the this means add to the beginning, before the head. To add before the head, we make next of our new pointer point here, then head point here. Okay. If not, if he said, for example, student 200, then we will not enter this one. We will enter this one. While we did not reach the null and we did not found the student number, move to the next. Make Q point to the previous and P to the next. Okay, 200, we found the students. Then we go here. We check if the students on P, yes, on P, then we add before it. How to add before it? We make a Q next, point here, and a new next, point to P. Okay, another case. If he said add to 0 to the end. So student number not at P, P starting from here. We moved until we reach the null. So if we reach the null, then we adding at the end. To add that at the end, we make the next of P, or last one, we will reach here, pointed to our node, and our node next pointed to null. Why? Because, as I said, head should always be as the first node. Last node should always point to the. So if we want to add at the end, we make the last end node point to our node, and our node point to the end. Then our node becomes the tail of the list, or the end of the list. Okay. Delete student. Also, we searching for student number, and then if we deleting at the beginning, if we deleting the head, we should make the head point to the next. Then we free the memory from here. If we deleting in the middle, like this, okay, we make the previous point to the next, then we free the memory. If we deleting last one, actually last one same as the middle. If we deleting last one, we make the previous one point to the next of last one, which is the null, then free the memory. I don't want to repeat it because we already take it. The new thing is find the student with the highest total grade. Okay, find the student with the highest total grade. First, we will move one by one, then calculate the grade of the students. Okay. And consider first one is the highest. Then after that, we will compare with the next one. If next one highest from our previous one, then we change the highest. So it's like this. If we have linked list like this, to make it simple for me, for example, if the midterm exam for this one, 60, and the final exam 60, here 50, 50, mid and final. This one, for example, 90, 90, and this one 70, 70. I make it similar because when I calculate the average, it will be 70 for this one. If I calculate the average, it will be 90 for this one, 50 for this one, because he take in the midterm and final same one. And instead of calculating for our example, it's better to have this one like example only. Okay, of course we have head here. So to find the highest total, first we need P here. It's same like a previous example, okay? When we try to find the longest string, now we try to find the highest total grade. So we need P, we need highest. Also, at the beginning, we consider first one the highest total grade. Then Now, until P next not equal null, it's not equal null, move P to the next. You see this one in the correct order, not like the previous one. We should move next first and compare our current highest with the new. So we need to calculate first the total grade. We make a small function to calculate the total grade. Actually, total grade like this. We take the midterm final, we multiply midterm by 0.4, we multiply final by 6 and make summation. This will return the total score for the student or the total grade for the student. So we calculate the total grade for student at P, which is 50 here in our example, and total grade for highest one, which is on the top now, which is 60, then become the total grade 60. Is it bigger? No. We continue. What's the meaning we continue? We still have the highest in the first one. When we continue, P next equal null? No. Then move P to the next. Now P pointed here. We ask the total grade for P, which is 90 here. And the total grade for the highest, which is 60. Is it bigger? Yes. Yes, then we need this one to become the highest. Yes. So we move highest to P. Highest become same like P. Now we move P next. Is it equal null? No. Move P to the next. And we ask now P here and highest here. We ask the same question. Okay, P total grade will be 70. And highest total grade will be, when you multiply 90% by 90 by 4% and 90 by 6% and make summation, it will be 90, the total grade, okay? So this is the highest, and this one, P, is it bigger? No. So move to the next. Okay, P next, is it equal null? Yes. So we will not enter this while loop. Now, highest point to the highest one. So we can print the student information with the highest grade. We can print student number, student name, and highest grade. So highest, this means a pointer, dot a number. This means a student number with the highest grade. Student name was the highest, it pointed by highest, and total grade him. So total grade for him. Like this, we found the student with the highest total grade. How to calculate the average for all the students? To calculate the average for all the students, we will calculate for each one. So we need total grade for each one, and we make summation between total grade. Then the summation will be divided by number of students. Like this, you can calculate the average. Total for student 1 plus total for student 2 plus total for student 3. Then the summation divided by number of students. So we need the summation, and this is the class average. Okay, it's 0, and counter to count the number of students. Then we need P to point to the head. If P equal null, then the list empty, else we will move P one by one and make summation equal the old summation. This means sum equals sum plus total grade. So first thing, P at the first node, then P move to the next, P move to the next, and so on. Every time P moved, we make summation between total grade of the students and the previous summation. Like this, we give summation, we take summation for all the total grade of the students. Every time P to the next, and we count the number of the students. After finish this while loop, we will have the summation for all total grade and number of students. We divide the summation by the number, we will have the class grades average. We can now print the average. Okay, this is the full example. We have menu. Every time we print the students' information, and then we ask the user to select which operation, and this one to create the list, this one to add a student, delete a student, and get the highest total grade, and get the class average. Just we calling the functions. We can see the run of the example. Let me, okay, this one. I think this example. This old example, I think. Yes, it's the example from the first. This is our current example. We have the node. We created the node, and we have the create list function, and we have the traverse, or listing the student or printing the student information. And we have the add, delete, find the student with highest total, and calculate the average. And this is the main menu. So at the beginning, we have the main menu. We need to create the list. For example, we have 2 students, student ID 100 and name Nihad, midterm 70, final 90. Okay, student number 2, insert record number 2, student 200, for example, Omar, and 90. Okay, now it's a print record 1 and record 2. We have this students with this total grade. Now we can add a student Okay, enter the information about the student, for example, 300, and it's his name Lana, and midterm 80 and final 85. Okay, uh, before which one I want to add at the end, so I will press 0. If I want to insert before any of the student, I have to give the number, then it will be inserted before it. Okay, I choose to add at the end. Now we can find the highest grade. We will choose 4. So the highest student total is for Omar, which is 90. Okay, calculate the average. I will choose 5. So the average it's 85. Yes, you can calculate it. Take a 3 here and take 2 here. So it's 85. Okay, delete. We can delete, for example, students with 200. Okay, I delete student with 200. Now we have Nihad and Lana. We can find the highest one. It's become Lana, of course. And the average, it should be 2.5, I think. Yes, 82.5. Okay, this our second application. We have a third application also. Okay, I think here. Okay, third application. We have a linked list. I want to add only 2 operations, so all the previous operation I will not put in the slides here. It's similar. I will put only the new operation. Then we have students, have data, number, and the grade. We can add and remove list students. We already know this. This is 2 new operation. Sort by grades. I need to sort the list itself. So if you enter the list like this, have student number 100 and it's a grade 90, and another student 200 and it's a grade 80, and so on. I need it to be order ascending like this. Student with 80 should be at the beginning, then 90, then 100, and so on. So after inserting, I will insert anything. Then after inserting, we need to sort. Okay, we talk many sorting algorithm. We will use something similar to bubble sort, that we need 2 loops. Okay, we need 2 loops. Then first loop, we start from the first node, comparing it with all nodes. And we change the lowest one with it until we found lowest one here, or smallest one. Then next time the loop will start from here with all nodes, and this becomes the next lowest one. Then next time we will start our loop from here, and we compare with all other ones, and so on. Okay, so it's similar like bubble sort, but in the bubble sort we put the biggest one at the end. Now we put the smallest one at the beginning. Just this is a different, but we need 2 loops, same like bubble sort. Okay, another process, we need to reverse the list. This means if we have list like this, we need this one become the head and this one after it. Reversing the list, idea like this. If we have this list, if we have list like this, here's the head, okay, and it's have information like this, for example, 190, 80. I want to reverse it. To reverse it, I need to make each pointer from here. Actually, I will keep it as it, but I can change the pointer. This one will become like this, 80 point to the previous one, 90 point to the previous one, and this one point to the null. And then move the head here. It's same. So I make this one point here, make this one point here, and this one point to the null, and move this head here. Then like this, I reverse the linked list. To use this, I need pointer to the previous, pointer to the next, okay? Then after reach the final and flip everything, I will make head point here. Okay, we will see how to use this. It's very simple how to reverse the list. Let's start from how to sort the list. So we will have this algorithm or this function to sort the list. It's similar like bubble sort. First, we check if the list is empty, then we finish. If not empty, now we have our sorting algorithm. Actually, we will not change the places. We will change or swap the values. So if we have like this, student with information, its ID, for example, 100, and its a grade. I want to sort depending on the grade, okay? And it's a grade 90, student 200, it's a grade 80, and student 300, it's a grade 85. So head always point here. It's like this. I create pointer named current will point here. Okay. And pointer name index point to the null. Still not pointing to anything. Now I check if the head empty, then we don't have anything inside this list. Else, we will make the sort. We need two loops. First loop pointing to the current. And loop for index. It's like when you have a stage and index. Current, this means current stage. We still searching for lowest value to put it in the first one. This is the meaning of current stage. Index, this means the index that will move inside the list. And always index start from the next of current. So if the current here, then it will start from here. Next time we finish an order and take first one, the current will be ordered one, and in its place, we will start the current from here and index from here, and so on. Okay, so now index point to the next of the current. Now we check if the grade in the current bigger than the grade in the index. Grade in the current, this means here. If it's bigger than, then we will swap because we need here the smallest one. So, is it bigger? Yes, in the current we have 90 and in the index we have 80. So, this is correct. We will swap, but we will swap the whole data. We have two types of data. We have the ID or the number of the student and the mark. So we need now two integer value. One for the number of the student, we called it temp1, and one to swap. Swap, I think we already take it many times. Even in the midterm exam, you have a swap. Okay. temp2, it's to swap the grade. So I will put first, I will put current number into temp1, which is 100. And current grade into temp2, which is 90. Then I can copy the data here. So make current number equal index number equal this one. So this one become 200. Then we are swapping the data, not the pointer here. We keep everything in the linked list. We just swap the data. And current grade, it will take a grade from here, then become 80. So we copy this data here. Now we can take from temp here to swap between current and index data. So index number become temp1, which is 100. And index grade become temp2, which is 90. So after finish this swap, the data here become 280 and here 190. We swap the data. Okay, now index move to the next. Index here move to the next. Current is still at the beginning. We reach here. This means the while loop. So we check index, it's equal null. No, not yet. We check current grade, this one, with the index grade. Actually, no. Current grade not bigger than index. Index now here at the 85. So we will move index to the next. Now index move to the next, which is null. So index to the null, yes. Now we finish this iteration, first iteration in the while loop, in the inner while loop. Now current move to the next. We already ordered this one. This one, the smallest one now. Now current come to the next. Okay, same operation. We compare, yes, it's smaller, then we will use the temp to swap the data. Then this one 85, 300, and this one 190 become. Okay, current to the next, now current to the null. So we will stop. Every time index will start from the current next, every iteration, okay? You have to focus here. In every iteration, when we move current to the next one, also we bring index to the next of the current. Like this, we can make sorting. What about reverse the list? To reverse the list, this is the process. We have list like this. We reverse only. You can see we are swapping here, but we are swapping what? We are swapping the pointers. Okay, another time. We start from 2 pointers at the previous and index at null. Then current at the head. We moved the index. You can watch it again and again until understand it. I can move to this one and describe it here. Okay. We want to reverse this linked list. Doesn't matter what is the data. Okay. We just reversing it. So we have head like this. Okay, and this one pointed to the null. Okay, actually to reverse it, this one, as I mentioned, if we have A, B, C data, doesn't matter what's the data. Actually, each one, we will reverse the pointer. So the pointer from, instead from A to B, it will become from B to A, and from C, instead of pointing to null, from C to B. And then A will point to the null, and then we will move the head here. Okay, first to do this, we need pointer here to the previous and pointer to the next. Next n, I will name it. And pointer to the current. We need this pointer to make something. No, it's the current. And we will use next to make a swap. Okay, like temp. Next will be like temp, but it's from the type of node. Okay, at the beginning, it's like this. Oh, it's much easy to delete everything. At the beginning, we have the list like this. Okay, node A, B, C, and we have head. Okay, at the beginning, we define a previous, next, current. We make a previous and next to the null. We have null here. We have previous and we have next n, next node. Okay, and we have current pointed to the head. Now, if the head null, then it's empty. Okay, else it's not empty. We need to reverse. We check if the current reach null, we stop. Current still in the head. Now we make next node equal current next. So next node pointer will become here. This is the current next. And we make the current next this is the next of the current, yes, the pointer, next pointer, equal to previous null. This means we moving this instead of pointed to B, because this will become the end, yes, and this becomes the head, point to the null. So we will move this pointer from B, it's next of the current, to become like previous, which is null. Okay, so we are like swapping. We make the next here, current next become here, previous become like current now, previous here, and current equal next, current moved here. Okay. Now we have a previous to this one and current to this one. Then we can move next here and make the pointer pointed. Current to the null, no, it's to the B. So we moved again. Next become next of the current here. Current next, we are current here, pointed to the previous, which is this one. So this pointer current next, now it will point where? To the previous, here. Okay. And the previous will move to the current now, and current will move here. And this become previous. Okay. Then current, is it to the null? No. Another iteration. Next n equal current next. So it will become to the null here, like the current next. Okay. Current next point to the previous current next, which is here. Yes. So instead of null, now next pointed to the null, but current next to the previous. Okay. And the previous move to the current. And current move to where? Move to the next, which is null. Now current here. Okay, again, current, not null? No, it's null. Then we finish. What we still have, now if you can see, now B point to A, C point to B, and A point to the null, we still want to move the head here. What pointed here? The previous. So head equal previous. This means move head to this one. Like this, we reverse the linked list. Now, if you want just to reorder it, we have the head like this, which is have C. And it's pointed to B. And B pointed to A. And A pointed to null. So, as you can see, we reverse this linked list like this. If you want to check the idea here, previous and next, start from the null, this moving each one. Okay, we can check the code for this example. We still have only 5 minutes and we finish. Just we want to see the example. This is the example. Same idea, just we add 2 functions. So we have node for the student. We can create list. You know how to create it, how to traverse it or printing it, and how to add a student, how to delete a student. Now this is a new part. How to sort the grade, how to reverse the linked list, and this is the main menu. We can run it. Okay. We want first to create the linked list. How many students? For example, 3. We have student ID 100. It's a grade 80. Student ID 200. It's a grade. You can put name and everything. I want to make the code shorter. That's why I put only ID and the grade. Okay, 70, 300, and we have a grade, for example, 85. Okay, so we have 80, 70, 85. List now like this, 80, 70, 85. Let's order it, sort, which is for. Okay, now 70, 80, 85, and of course, the whole student data we moved, not only the grade. We have student 200 have 70, student 200 have 70. If we have name and everything, we have to swap all the data. Okay. Now we have linked list like this, have student 200, then 100, then 300. I want to reverse it. It will be student 300, then student 100, then student 200. So let's reverse it. We reversed it, 300, 100, 200. Okay, like this we can reverse the linked list, and that's all for today. Thank you for attending the class, and see you inshallah next week. Guru Shurus, good luck for all of you, and have a nice week. Assalamu alaikum.